Yes, okay. My name is Kenny Toyonaga. I tell you a little bit about the EF Polymer, and this is a private company. It's an agri-tech, as I'm dressed in the vision casual shirt, and we do tackle the water challenges in global area. We started out in Japan, but the manufacturer is in India. But we use this polymer is a little bit of I guess the lack of the terminology because we don't use any chemical-based or petrol-based polymer. So I want to start with uh, next slide. This one. Okay. Yeah, just like every journal article, I want to start with a problem statement. So because we have an original tie with the country of India, the west of India has struggled with many drought issues. The founder of this company actually is the son of the corn farmer. So his dad had an issue with irrigations, and the big problem was that he was again in irrigation in his soil to be able to continue the nutrient in the soil. So the corn did not grow 1 year, and they had no productions of that year. So the issue is decrease in sowing area and water stress, the groundwater and increased cost. The fertilizer price has gone up, skyrocketed globally. And that, of course, decrease the incomes, and a country like India that doesn't have a lot of agronomists or support from the government really struggle. That it really hits the farmer in his pocket and income. And of course, you know, the country like US is a little bit more saturated with programs like this. So the farmer from US farmer gets some benefit from USDA, but we also think that the funding is you know, people are having an issue right now. So polymer is like a hydrogel, and it comes in the granule and powder forms. It produces 100% natural and biodegradable super absorbent polymer. It is made out of the hydrogel from the compost from orange and banana. So when you eat banana and orange, it has the peel that capture all the moisture inside of the fruit. And then the juice is usually pretty well kept. So that's how he kind of came up with this idea. And he started doing the experiment with the university in India and also in Okinawa, Japan. And that's when the idea became a business. So right now we have the data that helps with farmer decrease water by 40%. That can depend on the crop. So we're working with soybeans, corns, milo, and other produce. But we do a lot of, we're trying to test out with different soil types and soil quality. So yeah, this is my first talk in the US. So I'm trying to better explain this in English, but yeah, so the climate change, you guys probably know this, 45% world population facing brutal drought, and it's increasing as we have more population. Japan also has, Japan is surrounded by ocean. A lot of people don't know that we do also struggle with drought because the rain cloud doesn't come as predicted, and that's when a lot of farmers, like a wasabi farmer, daikon farmers, and these people lose profit. US has more widespread because a lot of these places are below sea level. India has a lot of population, but not a lot of land. And Western India is constantly hit by drought. So drought is a kind of a loose term right now, but the mission of the company is to try to solve this as Mother Nature created these things to solve orange peel and banana peel. Yeah, so our product is made of bio waste. So we can do, I'm sorry, this is all metric system, 8 kilogram per acre. We apply 8 kilogram of this product and you can expect about 6 months effectiveness. It's fully biodegradable for 1 year. Once again, it comes with this powder or granule shape. And you can see the product video. I don't know if I embed the video here. Oh, nope. No. Here. So here's a link on the bottom here. Oh, it's okay. Yeah. So economically, environmentally sustainable, we can reduce 40% less water, 20% less fertilizer, and 50% yield increase. And right now, this data is coming from India. So we're trying to localize this data here in the US, and especially in the area like here, Colorado, Eastern Colorado, Western Nebraska, Western Kansas, Northern California. So those are the area we're trying to go see if this has a space in the US market. So the way that we apply this product is we mix this with salt seed, and also we have a way to mix with infra in the soil. And tractor type that's commonly used in the US, Kubota or the John Deere. We try to also understand what kind of application works the best. Of course, if we're the conventional chemical company, we want to capture as much land as possible. We're working with very small land right now. With some of these people today are some of the collaborators. So farmers looking for the produce, and we are always farmer thought. Farmers the one that drives our product. We always want to listen to the farmers, and so we can do the optimize for agriculture, and we want to increase the long term. So we also don't want to destroy the soil, topsoil of the dirt, because this creates the erosion, and it could also get washed down to the next farm, and it can create that issue in enlarging that area, depending on the steepness of the land. And Japan is relatively a rugged terrain country, so a lot of those terrains, they share the same area, landmass. You get washed down to the area, and it really decrease we kind of spoil the land by applying too much fertilizer with the NPK. So our product doesn't have NPK. It has a little bit of naturally occurring potassium. The label has been approved for commercial sales in little bit less than 10 states at this point. Yeah, so this is the benefit. We want to highlight the income part of it, because the farmer is always looking to increase the farm income. So income is the way we can save probably the most 15% income. But talking to attending this session today or yesterday was the maintaining operational, but I got a lot of good information I can report back to the headquarters. That a lot of people are looking to monitor the drought, but also make sure that there's no irrigation or there's no erosion in the land. So I learned that today that not everyone's looking to decrease or increase the soil moisture, but that is our ideal market, is to go to the states that is struggling with the below average precipitations. So this is the picture that was captured in Okinawa. This is a visually confirmed sugarcane that we have done some trials with. And this is a very typical sugarcane area in Japan. It's an island called Okinawa. There's probably many people familiar because of the U.S. military base presence there. We used the fertilizer spreader, and EF polymer was spread both sides, and you can tell that really the growth was visible. Confirmation was exactly the same spot. So this is private farm we did the trial with, but we also want to localize this type of trial and hopefully with farmers, because farmer can be a walking testimony kind of a person. But we also rely on the university data because that makes the that makes our data more verified. So we're always looking for the collaborators. So with our vision, we have patented our technology. We want to upcycle the bio-waste, help farmers fight against drought and fertilizer cost rise. So bio-waste are very interesting because India and Japan produce, or India mostly produced high production of banana and orange. So they want to upcycle that to be used on the different reasons, because that is a significant waste that we're looking at, throwing away those peels. We also go beyond the agriculture market. Our first focus is always agriculture, because we want the producers, farmers, growers to be able to see these benefits in the site. But also this is the the biodegradable polymer. Currently, the market doesn't really have a lot of space for it, but we also want to expand into these different areas of industry eventually. So yeah, we're a very small team here in the US still. We have one agronomist in Northern California, and we have sales and distributors here in the state. But yeah, if you know a distributor that is kind of like this market, I would really want to talk to them. So I don't want this to be like a sales pitch, but we are the user of the soil moisture data. We really take the data into account and see which one works the best in the geographical area. So we have been funded by a lot of these agri-tech startup funding and also the Ministry of Farm or Ministry of the Agriculture of Japan. And also we're getting a bioprepare and OMRI certificate currently. So we are licensed in Texas, Georgia, North Dakota, South Dakota, Washington, and Nebraska, and Montana. We forgot to mention those. So we like to fully go commercial with these states. So what's next? How would this translate to the US market? So we're doing some research using the climate.gov data. A lot of states we know that are already used to drought. Like California here is a white. I think this data is showing the sustainability to each state. So California has already have a technology to combat the drought. So how would that translate is very good information. And also the thirsty crop, we're looking at the commodity that's very thirsty. So we're looking at sunflower, alfalfa, citrus, cotton. Those are something that really experienced a high affected by the drought. Yeah, so and we want to know the researcher or farmers, and we also want to publish in the research market. So this is my EF polymer. Yeah, thank you.
Questions for any?
So we try to understand the data, looking at the soil moisture in different soil, so fields or other crop or types. And we have different data based on the crops and soil types in the US. So that's where we want the most agronom or agriculture, the farmers are stressed. So the data we want to see is that the variety of different states and crop types.